Namaskar everyone. Indian Master Ji welcomes you to this YouTube channel. In the last video, we saw about median and quartiles. Today, we will take an example based on the same concept. So let's begin. This question is from October-November 2009, paper variant 71, question number 5. What is the question saying? The continuous random variable x has a probability density function given by f of x is equal to k cos x when x is between 0 to pi by 4 and f of x is equal to 0 otherwise, and where k is some constant. What are they asking? The first part of the question says show that k is equal to root 2. So let's prove that. Let's try to show that. We know that for any probability density function of a continuous random variable, the total area under the curve has to be equal to 1, correct? So that means if I integrate f of x with respect to x for all the real values of x, this integration has to come equal to 1, correct? So that means I can integrate k cos x with respect to x from 0 to pi by 4, and this value will be equal to 1, correct? Now, before 0, from minus infinity to 0, f of x is 0. So that's the reason we are not including that. And from pi by 4 to infinity, f of x is 0. So we are not including that. So we are going to integrate only k cos x dx from 0 to pi by 4. So k being constant, I take outside the integration sign. So I will have to integrate cos x dx with respect to 1. Correct? And this integration, this total value here to the left hand side has to be equal to 1 on the right hand side. Correct? What is integration of cos x? Derivative of sin x is cos x. So integration of cos x should be sin x. Let's put the limits. What are the limits? X is varying from 0 to pi by 4. Correct? So k into sin pi by 4 minus sin of 0 will be equal to 1. So what do I get here? I get this as k into sin pi by 4, that is sin 45 degrees. Sin 45 degrees is what? 1 upon root 2, and sin 0 is 0. So that means k upon root 2 is equal to 1. It means k is equal to root 2. Correct? So we are done with the first part of the question. So that means f of x is equal to root 2 cos x. Correct? For the interval x lying between 0 to pi by 4, and this is equal to 0 otherwise. What is the second part? They are asking, they are saying find probability of x greater than 0.4. So probability of x greater than 0.4. So that means they are telling us to integrate this particular curve of f of x. If f of x is some curve, okay, if f of x is some curve like this, and this is suppose 0.4 here, so from 0.4 till 4, they are telling us to integrate. From 0.4 to 4, pi by 4, in fact, they are telling us to integrate. Correct? So let's try to integrate this particular curve. So from 0.4 to pi by 4, I'm going to integrate root 2 cos x with respect to x. So what I'll get this as, this will be equal to root 2. Outside I'll take integration of cos x dx from 0 to pi by 4. So this will be equal to what? This will be equal to root 2. Derivative of sine is cos, so integration of cos is sine. So I'll put sine x here inside, and the limits will be from 0.4 to 5/4. So this will be equal to what? Root 2. In the calculator, I will keep the radians mode on. So sine pi/4 minus sine 0.4. Correct? So this will be equal to what? This will be equal to root 2. Sine pi/4 is 1 upon root 2 minus sine 0.4 will be something as 0.38941 something something. If we solve this whole bracket and I multiply the answer with root 2, what do I get? I get this as something as 0.4492 something something. So in 3SF, I can write the same thing as 0.449. Okay. So this answers the second part of the question, that is probability of x greater than 0.4. Now what is the third part? They're saying find the upper quartile of x. So what is upper quartile of x? It is that value of x to the left of which the area under the curve of f of x is equal to 0.75 or it is 75%. Correct? Let's try to find that. I'll take a new page. Suppose I say let R be the quartile, upper quartile. R be the upper quartile of x. Okay. Then I know that probability of x less than or equal to R is equal to 75% or this is equal to 0.75. Correct? So therefore, I will have to integrate the f of x curve from 0 to R, because to the left of 0 the curve is not defined. So I will have to move from 0 to R only. So 0 to R, from 0 to R I will have to integrate root 2 cos x with respect to x. Correct? And this value will be equal to 0.75 or 0.75. I can write it as 3/4 also. Correct? So therefore what I'll get? I'll get this as root 2 into integration of cos x, again will be sin x. 0 to R will be the limits, and this will be equal to 3/4. So from here what do I get? I get this as root 2 into sin R minus sin 0 sin 0, and this will be equal to 3/4. Sin 0 is 0, so what do I get? I get this as root 2 sin R is equal to 3/4. So that means sin R is equal to 3/4 into root 2. Correct? So this means that R is equal to sine inverse of 3/4 root 2. So if we solve this on the calculator, what value do we get? Get this as 0.5589 something something. It means R is equal to 0.559 in 3SF. That means my the upper quartile is 0.559. Correct? That answers the third part of the question. What is the fourth part? Find the probability that exactly 3 out of 5 random observations of x have values greater than the upper quartile. They have the values greater than the upper quartile. 3 out of 5 random observations of x greater than the upper quartile. Now, if x is less than the upper quartile, then what do we know? Let me write it with a different color here. I know that probability of x less than or equal to r, if suppose r was the upper quartile, that probability of x less than or equal to r was equal to 0.75, correct? That means probability of x greater than r has to be how much? It has to be 0.25, correct? That's what they have been asking here. They are saying that the x has values greater than the upper quartile. So that means this probability is equal to 0.25. And 3 out of 5 random observations of x they are saying. So can we say, suppose y is some random variable, let y be the number of observations, y be the number of observations out of 5 of what? Of x, okay, which have values greater than the upper quartile, correct? Have values greater than the upper quartile, greater than the upper quartile. So if that's the case, then probability of the x having a value greater than the upper quartile is 0.25. So this value is fixed always, correct? So this I can consider as a probability of success, and value less than the upper quartile is also fixed, then it is 0.75. So I can consider this as Q. So I can say that y follows a binomial distribution. Y follows a binomial distribution n comma p, where n is what? Where n is 5 and p is how much? P is 0.25, correct? Now they are asking us that out of 5 observations, 3 observations, that is y is equal to 3, they are asking us to find out what is this probability that y is equal to 3. Okay, they are asking. So how do we find it out? We will use the binomial distribution ka formula to find out the probability. It will be what? NCR into p raised to r into q raised to n minus r, correct? So 5c3 into p is 0.25 raised to r is here 3 into q raised to r, that is 0.75 into n minus r raised to n minus r, so that is 5 minus 3, correct? So if we solve this, what do we get? The whole thing if we solve, we get something as 0.08789 something, which I can write it as 0.0879 in 3SF, correct? So this answers the 4th part of the question. Okay, that's it for this video. Thanks a lot for staying together this long with this video. If the video was useful and you enjoyed watching it, then please like and share the video. Subscribe to the channel and press the notification bell so that you don't miss any updates from this channel. And finally, till we meet in the next video, stay healthy, stay blissful. Radhe Radhe.